Hey guys, today we are going to learn about properties of logarithms. We're going to learn how we can write logarithms in expanded and condensed form using those properties. But first, let's review some properties of exponents. When we multiply exponents like a to the 7th times a to the 3rd, we add the exponents. So a to the 7 times a to the 3rd is the same as a to the 7 plus 3 power, or a to the 10th power. If we have something like a to the 7th over a to the 3rd, we are dividing. And when we divide with that same base, both have base a, we can subtract the exponents. So that's a to the 7 minus 3 power, which is a to the 4th power. And when we raise an exponent to a power, so a to the 7th to the 3rd power, we can multiply the exponents. So that's a to the 7 times 3 power, or a to the 21, a to the 21st power. Okay, now for logarithms, the product rule says that the log of a product equals the sum of two logs. So if you have, for example, something like log base a of x times y, that is the same as log base a of x plus, so that's the sum, log base a of y. Okay, and so you can go back and forth between these two forms. So you've got your condensed form and your expanded form. So we're going to write some logarithms in expanded form. So we've got here an argument that is multiplied 9 times 2. So we can write this as log base 4 of 9 plus log base 4 of 2. So that is the expanded form. Here we've got a product, x times x plus 6. So we can write in expanded form as log base 7 of x plus log base 7 of x plus 6. And here we have a times b as our argument, so we can write in expanded form of log base 2 of a plus log base 2 of b. Okay, so now we've got some that are already in expanded form, and we want to go the other direction. We're going to write these in condensed form. Okay, so notice we've got the same base, so we can condense these. Since it's addition here, we can multiply those arguments. So we've got log base 2 of 3 times 5. And we'll simplify that. That's the same as log base 2 of 15. Okay, once again, we have the same base on our logarithms, so we can condense by multiplying the arguments. Log base 2 of 4 times 3, which is log base 2 of 12. Okay, our next rule is the quotient rule. For logarithms, the quotient rule says that the log of a quotient equals the difference of two logs. Okay, for example, if you have log base a of x over y, so that's a quotient, division, that equals log base a of x minus log base a of y. Okay, so when you've got division here, you can subtract two logarithms with the same base. So here we have log base 2 of 27 over 16. And since this is a quotient, we can rewrite it in expanded form as log base 2 of 27 minus log base 2 of 16. Log base 4 of x over y is log base 4 of x minus log base 4 of y. And log with no base, that's actually a base 10. When there's no base there, that's a base 10. We'll talk about that in an upcoming lesson. So log 2x over 2x minus 1 is the same as log 2x minus log 2x minus 1. And I want parentheses there to make sure that whole thing there, that whole expression, is the argument. Okay, now we're going to take these expanded forms and put them into a condensed form. Okay, so that means we're going to write them in a single logarithm. Now this right here is meant to be a 4, so we're going to change that to a 4. So they have the same base. If they don't have the same base, we can't condense. Okay, so we've got log base 4 of 4c over 2c. And again, this doesn't work if we don't change that base. They were meant to be the same. Now this right here can actually be simplified. C over c cancels, and 4 over 2 is 2. So this is log base 4 of 2. And then the last one, we have the same base and subtraction, which means we're going to divide the arguments. So that's log base 2 of x over y. Our last rule is the power rule. For logarithms, the power rule says the exponent of an argument can be written as a coefficient. Okay, coefficient is the number in front of an expression, the number you're multiplying by. So for example, if you have log base a of x to the y power, that's the same as y times log base a of x. So to write this in expanded form, I can take this exponent 8 and move it here to the front as a coefficient. So this is the same as 8 times log base 4 of 16. And I can take this power and move it to the front as a coefficient. 3 times log base 3 of 3. And I can take this exponent and make it a coefficient. 8 times log base 5 of 6. Okay, now we're going to take these expanded forms and write them in condensed form by taking this coefficient and going the other way with it and making it an exponent. So I have log base 7 of 49 to the second power. I'm going to go ahead and simplify that. 49 to the second power is 2,401. So this is the same as log base 7 of 2,401. And then I've got a 4 as a coefficient. I'm going to move that back here as a power. So I've got log base 5 of 1/25 to the fourth power. If I'm going to raise a fraction to a power, I need to put that fraction in parentheses so that power applies to the whole fraction, top and bottom. I'm going to simplify this also. So I've got log base 5. 1 to the 4th power is 1. 25 to the 4th power is 390,625. And now I've got a couple that I want to condense using more than one property. Okay, so here I've got a sum and I've got a difference. So I'll start by condensing these. And since I'm adding these two logarithms with the same base, that means I can multiply the arguments. So I've got log base x of 9 times 4. And then that subtraction means I'm going to divide. So I'm going to divide by 8. Okay, so that is log base x of 9 times 4 is 36 over 8. And 36 over 8 can be simplified. I believe 4 goes into both of those. So that's log base x. 36 divided by 4 is 9. And 8 divided by 4 is 2. Log base x of 9 halves. And last, we've got 4 times log base 2 of 6 minus log base 2 of y. I've got a coefficient here that can be moved here as an exponent. Then minus means I'm going to divide. So I've got log base 2 of 6 to the 4th power. And that is going to be divided by, because of that subtraction, by y. So I need to figure out what 6 to the 4th power is. So 6 raised to the 4th power is 1,296. So this is the same as log base 2 of 1,296 over y.